Okay, like I said in our first part, we had just like little introduction of what we have made, and that was an oximeter using our lm386, which is an audio opamp. So let's get back to cable, which is very important part, how to make cable. In making cable, we need to know first we need to connect 3 wires, even if we have 4 connections, and for that we will use audio cable, which has ground connected to this bit there, which is first ring. Then we have power 5 volts that will power LED connected here, and we have power of 5 volts connected to infrared detector through the resistors, obviously, and this one is going through resistors, which is 150 ohms, that middle one, and I use spot, which is 1k, so that gives me really a lot control over the LED. And on detector we have around 200k, not just resistor. We have a 83k resistor and we have a 100k potentiometer. So let's get back now to how we need to connect our LED. First, LED, you can use your multimeter and connect a black one to, let's say, this wire, which is minus here, and red one here. And if you get your LED light to actually show you light, a little bit of light, then you have that connection right. If you don't, swap it, simple as. So you want your negative to be on this side and positive on this side in this example. Your detector connect as well to multimeter, connect to, let's say, 2 meg on your multimeter, and put black one, let's say, on one side and red on the other side, and move it around in daylight, and you'll notice where you have bigger source of daylight that actually resistance changes. If you notice that, and your black one is connected on multimeter on this side, red one on this one, then you have them right way. Now you need to connect your negatives into one, and we have done that by doing like this, yeah. And then on our cable we'll have ground, which is brown, and blue one, which is powered in 5 volts to infrared LED, and the red one will power, let's say, your detector. So let's get back now to cable. Connect multimeter to your blue one, let's say, or whichever color it is. First connect multimeter to ground, black one, and find with your other end of your multimeter ground here. Then connect to any wire, and if you detect that middle one, and that happens that this is blue one, then blue one you will connect to your LED, and connect multimeter to your red, and then connect it to your bottom one. Sorry, I moved it off. Connect, let's get back, ground to multimeter and check it here, where do you get reading. Then connect your detector on multimeter here and connect it on bottom one, and you should get reading. Then connect your blue wire and middle one in this section there, and you should get reading. So if you connected everything right, that's how it should be. On your jack, audio jack, you have ground connected here and that will be connected when you plug it into this one. You have your LED light on your this side, and these two are like one, they are connected anyway, and on the other side you have two, they are connected as well, so it doesn't matter, they work as one. So that will be your detector. For this example I have used infrared LED and detector, which is rated as 900 nanometers, and that's very important. So if you have connected everything right, this is how it should look. So picture it or freeze it, or you can slow it, stop it, and that's it. You can make your cable and make your finger clip for your finger. So we will move now on to schematics, which is, in this example, I don't need this. I don't need those connections at all. Okay, we're going back to jack. So we have here ground, and it goes right to ground here. We have 5 volts going from here, and those 5 volts are split in two. One is powering detector through 100k pot, and it goes in 83k resistor, and it goes right in your audio jack, like we explained in previous example. And then your signal, when you receive some, if you don't receive anything, it will be 5 volts. So you have 200k roughly sensitivity here, and if you receive signal, it will drive it to the ground. So your signal will will be different between 5 and 0. Obviously, because of 200k, it won't be really that much down to 0, but 0 volts, but you will be able to fine-tune it yourself this way. Then signal goes out into capacitor. I will get back to signal after. So we go now on 5 volts again, goes here under this resistor, and it goes back onto 150 ohms resistor, and it goes on pot 1k, and it goes right in your jack, and that powers your LED. When you turn it to turn pot to minimum, actually only stays 150 ohms, and that's full power. When turn this to maximum, then your LED will be really weak, and that's what you want to set it up to really weak when you start getting your signal, and then gradually increase it. It's very important, because you will not get signal and you will be disappointed. Then once you get signal here on the screen, then increase sensitivity of your. So previously you have to put this pot to minimum as well. That means on this side actually, and then gradually increase it, and you will get a signal. So okay, let's say now we have signal. Signal is coming out here, and it goes in capacitor, which is I'm not sure what capacitor I have put in this schematics. Probably, I think, oh god, I have to have a look. I think it's 1 UF, and it goes through 83k right in your pin on your LM, pin number 3. Your LM is turned up this way. You have that little mark. That's your pin 1, 2, 3, 4, 5, 6, 7, 8. 7 is bypass, and we don't need it in this example. So our signal went in pin number 3. Number 2 is one of the inputs as well, but it's attached to the ground. Ground is attached to pin number 4, and pin number 6 is 5 volts that we get from this as well, and we power our LM. On LM we have one interesting thing to control the gain. If we take all this off and don't connect anything to pin number 1 and 8, we have 20, gain of 20. But if we connect only one capacitor of 10 UF without this pot, we will get 200 gain. And I put 1K pot so I can actually fine tune it here. And capacitor has to be, this end has to go positive side, has to definitely end up on pin number 1, and your negative side of your capacitor has to end up on pin number 8. So now when we have signal, we can move on to filtering. Signal goes here like that, and it goes in I have changed this in reality. I put one pot of 10K, and then in series I connected 22K resistor, and then that travels further down. But here we break it with an capacitor and ground it here to ground. This wire is connected to ground, as we can see. It goes here to ground. So value of this capacitor is 0.47 UF, and resistor plus pot is 32K. I have 22K resistor in series connected with 10K pot. That's 32. When you do your calculation, that will give you low pass filter ranging between 33 Hz and 72, so you can get rid of your 60 Hz. Signal goes further down to 100K resistor and 104 rated capacitor, which is ceramic, or value of that capacitor is 0.1 UF. You drive your signal here, and this I have added only 470K resistor to ground to get rid of some impedance, but you can get it out and it will just work fine as well. And then signal travels around and it goes right in your pin number A0. That's your analog A0, and that's when you get your signal. These in middle section you can exclude. I made that for reading signal after first, low pass after second, and we don't need it for this example, it could be excluded. Let's move on to the real signal now. Okay, let's move on to signal now. That's the reading that we get, and so if someone knows a little bit about the signal, you can see that you have two sections. Peak when it goes really up, and then halfway it stops and it moves the other way forward, and then it goes down. This, what you can witness on the screen, is my PVC. That's what is called premature ventricular contraction, and it's just because my heart is not bumping equally right. And as you can see, there is a gap between. Now this is okay. I made it program when it finishes about 100,000 samples, it just closes, but I can just reactivate it and it will do 100 samples. Yeah. So more or less, so this is end of it actually, how we make it, and what you get is pretty good clean signal. I would mention only that if you talking about 60 Hz noise, in this example you will get 60 Hz noise only if you have light in room, because light bulb flashes about 60 times in second, and that's reflected through your finger on detector as well. So if it's no light in your room, you will notice that you don't have any noise. But noise we can reduce on actually using that filter which we have and that pot. So more or less, that's it. Yeah, hope you can recreate it. I'll put this all downloadable, so you can download it, and I will make PDF file which is like it will be like manual, so you can actually have all details to talk you through and explain everything where you can fail and what you need to pay attention. But I'm sure that you will get the same signal as I do. And then we can do that to detect heartbeats and everything, and I'll make one little function as well to do that later. I have made in this program, actually each of these bars, as you can see, is 250 milliseconds, so you can actually, if you calculate the gap, you can tell what's your heartbeat, and then divide number of milliseconds by 60,000. You will get actually heartbeats. And that's it. Hope it's useful to all of you. Hope you recreate it and make it for yourself. Thank you for watching.